How are you, my viewers? I hope you're well. Welcome to this channel where we make chemistry friendly to all our learners. Today we shall have something different on anions that we said last time are negatively charged ions. We said that anions are negatively charged ions. And the anions that we are going to deal with today are oxygen and chlorine. Oxygen and chlorine are what we will begin with. So, starting with oxygen, we have the formation of the oxide ion, which has this formula, capital O, 2 negative. So as usual, there is this information that we are going to borrow from what we dealt with in our last two lessons, where we had the formation of cations. So the information that you are going to borrow from there is that when we are indicating the number of protons and the number of electrons for any given atom, always remember that those two are equal. So we begin with oxygen. Oxygen is atomic number 8 with electronic configuration of 2.6. When you look at this 6, it means that the second energy level is not yet full. Let me remind you of something about the filling of energy levels with electrons. Let me remind you of something that is very, very important, especially when you're dealing with the first 20 elements. The first 20 elements. So there are these rules that we follow when you're filling the energy levels. And I insist these ones are for the first 20 elements, because when you go up there from number 21 up there, some of the rules will change. So the first rule for the first 20 element is that the first energy level has a maximum of 2 electrons. A maximum of 2 electrons. The second energy level again for the first 20 elements, it has a maximum of 8 electrons. The third energy level, again for the first 20 elements, has also a maximum of 8 electrons. So let us look at our oxygen here. This is the first energy level with 2, and this is the second energy level. Remember, when we are dealing with sodium, I shown you how, just from the electronic arrangement, how you can determine which is the innermost energy level, which is the outermost, which is the first, the second. So, on the far right hand side, that is where we have the outermost energy level from the electronic arrangement of any given atom. So the outermost energy level is on the far right, and if it is the outermost for this oxygen, it is the outermost and it is also the second energy level. These two electrons are in the first energy level, and this first energy level is also the innermost energy level, meaning the position of the nucleus is just on this far left hand side. So you see now, for oxygen, the outermost energy level, which is the second energy level, it is not yet full, because for the second energy level, they should be having a maximum of 8. So now the question is, how many more electrons should oxygen gain so as to become stable? You see, any element that has fulfilled any of these rules, any element or any atom that fulfills any of these 3 rules, it is said to be stable. For example, when you think of helium, which has the electronic arrangement of 2 and just 2, it has a maximum of 2 electrons in its outermost energy level, so it is stable. And if it is stable, that means it is in group 8. The atom or the element that fulfills the second is neon, with atomic number 10 and electronic arrangement of 2.8. So you see, it has fulfilled the first rule with a maximum of 2 for the first and a maximum of 8 in the second. So it is also stable and in group 8. When you go to the third rule, where the second energy, here we said the second and it is supposed to be the third. It is supposed to be the third energy level. Sorry. And I hope you are also very keen to note it is just me who made a writing error. So the third energy level should also have a maximum of 8. And the atom or the element that fulfills this one, this rule number 3 is argon, with atomic number 18, so electronic arrangement of 2.8.8. So argon has fulfilled the first rule with a maximum of 2 for the first, a maximum of 8 for the second, and a maximum of 8 for the third. So such atoms or such elements that fulfills the 3 rules, either all of them or each one of them at a time, they are said to be stable. So look at oxygen here. It has 2.6. So meaning the second energy level is not yet full, because it has not fulfilled the second rule of the second energy level, how it's supposed to be. So oxygen must do something so as to become stable, because something is missing. So how many electrons is oxygen supposed to gain so as to fulfill that rule? It is supposed to gain 2 electrons. Why is it gaining 2 electrons other than losing these 6 so as to go back to 2? Because if it were to lose these 6, it will go back to 2 and fulfill the first rule, where it will only be left with 1 energy level with a maximum of 2. So it will be very easy for oxygen, or rather oxygen will lose little energy to gain the 2 other than lose the 6. And that is why I said last time that elements in group 5, group 6, and group 7 are nonmetals, and they react by gaining electrons. So for group 5, because they have 5 electrons in the outermost energy level, they only require to gain 3. For group 6, because they have 6 electrons in the outermost energy level, they only require to gain 2. For group 7, they have 7 electrons in the outermost energy level, they require to gain only 1. So it depends with how many an atom has, how many electrons an atom has, which is a nonmetal, and so that we can know how many it should gain, because depending on which atom you're dealing with, there is the rule that it should fulfill. So now we know oxygen we require to gain how many? 2 electrons. And always remember, electrons are negatively charged. So the side that you'll be adding extras is the side of the negatives. So as usual, we write downwards. The number of positives and also the number of positives and the number of negatives. So at this point, we say that oxygen has atomic number 8. So the number of protons are 8, and the number of electrons are also 8. By the way, the shorthand way of writing the word electron, we write a small e and a negative at the top. So now that it has 8 protons, it means that we will indicate 8 positives. Now that it has 8 electrons, we'll also indicate 8 negatives. So let us write them together. So oxygen atom, and on the other side we shall have oxide ion. We don't call it oxygen ion, we call it the oxide ion. So let us begin counting them together. 1, how many are we indicating? 8, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Up to that point, they are all equal. The overall charge is 0. And I said you can still try mathematically. Mathematically, it is said to have negative 8 plus 8. You have a debt of 8 and you have 8 shillings in your pocket. You pay the debt of 8, and with the 8 shillings you remain with a 0. So the formula for the oxygen atom is capital O, and no charge on top, because the 0 meant that it is neutral. Remember, for any given atom, the number of protons, which are the positives, and the number of electrons, which are the negatives, are equal, and that is what makes an atom to become electrically neutral. Then we go to the side of the ion. On the side of the ion, we still write the 8, 8. 8 positives, 8 negatives. 1, 2, 3, 4, 5, 6, 7, 8. Up to that point, each side has an equal number, 8, 8. Here we said that oxygen is required to gain 2 electrons, and we also said that the electrons is the side which has the negative. So in this case, there will be nothing to rub. You see, for the metals, we were rubbing some of them for the metals, because that was to indicate that metals usually lose. But for this case, they do not lose, non-metals gain. So you come to the side of the negative and you add 2 more negatives, but you have not indicated any positives, because oxygen, being a non-metal in group 6, it can only gain 2 electrons. We are not saying anything about the protons. The protons will remain the same number, 8, but for the electrons, 2 more will be added. So when you be writing the formula of oxide ion, we'll have capital O, the symbol for oxygen, And how many negatives are these? 1 negative, 2 negatives, 2 negatives. Then you combine the negatives. You say 1 negative, 2 negatives, so 2 negatives. 2 negatives. So this is the correct way. If you find yourself writing a -2, you fail. Because when you begin with the charge and then the number, that is the oxidation number. But for the charge, you must begin with the number followed by the charge. So that is all that you are going to have. So I hope you have understood something. You have understood something. And this time round, I began with the one that is gaining more than 1 electron. So for your assignment, make sure that you try the one for chlorine. And remember, chlorine being in group 7, it will only be gaining 1. So you can even predict how the stable of the chloride ion shall be. So make sure that in your own assignment you use the same knowledge and write show the formation of the chloride ion. Let me advise you on something. I know some of this information is in our KRB book too. But now that you want to try to see whether you can do it, don't just copy. Don't just copy to make me happy. Follow the steps that I have shown you. Try if you can do it on your own. If you cannot, indicate in the comment section what area is difficult for you. Remember, in this channel, our main agenda is to make chemistry friendly to you. And I believe one of these days you shall look back and wonder, what was that was very difficult for me to understand? So please have a change of attitude, and you will perform the best. So keep on working hard. Hard work pays. Tell a friend to tell a friend. If you have not yet subscribed, please consider doing so. And if you are a new subscriber, welcome home. Welcome home. Have a seat, write good notes, follow on each and every step, and where you have a question, remember, I am here for you. Thank you.